All right, so today we're going to be looking at Unit 7, Notes number 6. And we're going to, for today, be writing equations based off of our graphs. So far I've given you the equation, you've graphed it. Today we're going to go backwards. I'm going to give you the graph, and then you're going to write the equation to go with that exponential graph. Alrighty, so just a few reminders. When we write our functions, we're going to be using this form. So it's f of x equals a times b to the x plus d. Just a reminder on our transformation, so we're not forgetting. The a value stretches or compresses the function vertically. And it's a good thing to remember that if it is a stretch, that means that it's a large number. So greater than 1. That's going to be greater than 1. That's a greater than sign. Just doesn't look like it. Let me fix that. There you go. Greater than 1. And if it compresses the function, that's whenever it is a decimal or a fraction. That's less than 1. So in between -1 and 1. Now we also know that the a value also reflects the function over the x-axis. So that's whenever it's negative. Okay. Now the d value will shift the function up and down. I'm sure you guys have already filled all this in. That's whenever we talked about those shifts. And then the b value is the base. Alrighty, so we'll remember to find your base from a graph, because that's what we're going to be doing today. This is what we did back in that warm-up. So to find the base in the graph, you're going to make a mini table. And you're going to be looking for the pattern. I like this yellow color. Alright, so looking at number 1, it says write the equations of the exponential functions that represent the given graphs. So we're going to start by making a little mini table. And we're just going to identify points. Remember, the points need to be right next to each other, and you have to go from smallest to largest. So if we start with our y-intercept here at 0, 1, we have to pick the very next point to the right. So the very next point is going to be right here at 1, and that's going to be at 1, 2. So that's our little mini table. To find our b value, this is where we look for that pattern. So how am I going from 1 to 2? Remember, we only multiply, and we are multiplying by 2. So remember, that right there is our base. That makes our a b value 2. Now, from here, since there is no shift, okay, that means our a value has to be our y-intercept. Since there's no shift, our a value is going to be our y-intercept. So we know our a value here is going to be 1. So our b value is 2, our a value is 1. There's no shift up and down, so that means our asymptote is still at 0. Okay, so that means all we need is our a and our b. So we're going to have y equals 1 times 2 to the x, and we're done. There's no shift, so this is where you could write a plus 0 for the shift, but you don't need to. Alrighty, let's do the same thing on the next one. We're going to start by making our little mini table, just like we did in that warm-up. So we're going to start with I can't tell what any of these points are over here, because none of them are right on an exact point. So I'm going to start with 0, 3. And I pick the very next point at 1. So I go over to 1 and up to 1, 2, 3, 4, 5, and 6. So 1, 6. So I need to think, how do I go from 3 to 6? And we only multiply, and that's where we're multiplying by 2. So my b value is going to be 2. Since there is no shift, my asymptote is still at 0. That means our a value is our y-intercept. So that means our a value is 3. So now, since there's no shift, we know our d value would be 0, so we don't really need that. And so we'll have y equals 3 times 2 to the x, and we're done. Alrighty, Sweet. So let's go on to the next step. Write the equations of the exponential functions that represent the given graphs. Notice that these ones are all decaying. See how these ones are decaying? Since they are decaying, we're all going to write this up here so we all remember. That means your base is a fraction. Okay, since we are decaying, that means our base is a fraction. So we are going to start by making our little mini table. Now, if I were to start at 0, 1, I can't pick any of the points to the right. So that means you can't start at 0, 1. So we start with the negative. So we're going to do negative 1, 1, 2, 3. And then we can pick the one right to the right, which is 0. So it's going to be 0, 1. So then we need to think, how do we go from 3 to 1? Remember, we only multiply. So we are going to be multiplying by 1/3. Because 1/3 of 3 would give me 1. So that's what we're multiplying by. So my base is going to be 1/3. We also said that since it's decay, our base had to be a fraction. Well, guess what? It is a fraction. We weren't kidding. There is not a shift because our asymptote is still at 0. That means our a value has to be our y-intercept, which is 1. So we're going to write our equation. We've got y equals 1 times 1/3 to the x. Alrighty. Let's do the same thing on the next one. Pretty short, sweet, and straightforward. Alrighty. So on this one, we're going to start by making our little mini table. Again, we can't pick any of these points over here. So that means we need to start even further back. So we're going to start at negative 1. And 1, 2, 3, 4, 5, 6. And then our next point is going to be at 0, 2. So we need to think, how do we go from 6 to 2? What do we multiply by? And that's where we are multiplying by 1/3. So that means our base here has to be 1/3. And then since there's no shift, because my asymptote is still at 0, then that means my a value has to be 2. So we're going to have y equals 2 times 1/3 to the x. Alrighty, sweet. Let's go to example 3 on the back. So it says the graph shows data collected by a scientist in a lab. Each hour she records the number of skin cells growing in a petri dish. Use her graph to answer the questions below. So we've got a point at 0, 4, a point at 116, and a point at 264. So letter A says, how many skin cells did the scientist put in the petri dish to start? Well, we know we start at 0 hours. That's our starting point. Okay, so we're going to say, and we're looking at the number of skin cells. So 4 skin cells, because that's where it was at 0, 4. So 4 skin cells. And how do we know? Because that's my y-intercept. Okay, that's the starting point of our graph. Letter B says make a table to find the common ratio. That's going to be our b value as the base for an exponential function. So we know our first point was, we make our little mini table. First point was 0, 4. Our next point was 116. And then our next point was 264. So we need to think, how do we go from 4 to 16? Well, we're multiplying by 4, and if you check from 16 to 64, we're also multiplying by 4. So that means my base has to be 4. So from here, now that we know what our base is, there's also, you can't tell here, but there's not a shift, okay? This would get really, really close to 0, okay? Because you can't, if you think about it, you can't have negative number of skin cells. So to write our exponential function, we know we started at 4 because that's our y-intercept, so that becomes my a value. So we're going to have a y equals 4 times, my base was also 4, so 4 to the x. Now this next part says define our variables, so we cannot forget to define our variables. So that's where we have to think, let x equal and let y equal. Well, since we have a graph, that's actually pretty easy because we know our x-axis right here says time. You can also think about the x side of your table being time. Once we get to writing from a table, that's what we'll do. So we're going to let x equal the number of, what was it, hours. We're going to let y equal, if we look at our y-axis, that's the skin cells, so number of skin cells. So letter D says use your function to predict how many skin cells will be in the petri dish at 5 hours. So we just said x was the number of hours, so that means here x is going to be equal to 5. So we're going to take that 5 and we're going to plug it into our function. So we'll have y is equal to 4 times 4, and instead of the x, it's going to be to the x. Alrighty, so now we just have to simplify. Of course, I don't have my calculator on me, so give me just 1 second. 4 times 4 times 4 times 4 times 4, 5 times. Gives me 1,000. So we'll have 4 times 4 to the 5th was 1,024. So we're going to multiply it by 4 one more time. You can also just type this straight into your calculator, and you would get 4,096. But I didn't just ask what was the value of y at when x equals 5. I asked how many skin cells. So we're going to say after 5 hours. Remember, you have to talk about your input and your output. There are 4,096 skin cells in the dish. Okay, the next one says use your function to predict how many skin cells will be in the petri dish at 7 hours. We would just do the same thing. We're not going to worry about that at the moment. So you would just do the same thing. You would set it up and it would be y equals 4 times 4 to the 7th instead of to the 5th. So same thing. And then letter F says, is -3 in the domain of your function? So remember, domain is your x's. So that really just says, could I have an x value of -3? So that means, could I go up here to my graph and plot something at -3? Which would be like over here. Hopefully you're thinking, I don't think so. You're right. Okay, we could not have an x value of 3. That's because we said our x's, guys, were the number of hours. If you think back up here, we said our x's were the number of hours. So I can't have -3 hours. So we can't have -3 hours. Alrighty. Hopefully you got all this down and you listened to me with your headphones. If you did, you can move on to your homework.